All right, our last section of chapter 6 is still having to do with vectors, and it's going to introduce some different forms of the vector and talk more about the angles with the vectors. Because yesterday we talked about vector properties. We could do operations with them. We focused a lot on component form and magnitude, but we didn't really talk about the direction. Because we set up here that vectors have a direction and a magnitude. So rectangular form of a vector, that's in that horizontal component comma vertical component. You might also see it as v1 comma v2, and that's what we did yesterday with the operations for vectors. And now this polar information, the polar form tells us the magnitude and direction of the vector. And you say, well, how do we get the the rectangular form, those two numbers, if I just have the magnitude and the direction angle? Well, what we do is we take that magnitude of our vector and multiply it by the cosine of that angle, and then we take the magnitude of that vector and multiply it by the sine of that angle, and that will tell us, that will get us our component form with our horizontal component and our vertical component. So magnitude times the cosine of the angle, and the magnitude times the sine of the angle. So example number 1, we have our vector in component form. We're going to find the magnitude. We did that yesterday. And then we're also going to find the direction angle. Oops. So to get the direction angle is going to be the inverse tangent of the vertical component over the horizontal component, or if you want to think of it as the y over x part, if we're talking about ordered pair. And remember, tangent's also sine over cosine. Sine goes with y, so that would make sense to use the vertical or the y component of it. So let's look at example 1. We have our component form -2 comma 2. So let's first get the magnitude. The magnitude of our vector is going to be the square root of -2 squared plus -2 squared, which is going to be the square root of 8. We know that the square root of 8, if we break that up into 4 times 2, is going to be 2 times the square root of 2. So that is our magnitude, the square root of 2 over 2. Now, to find our direction angle, we have to do the inverse tangent. So theta is going to be the inverse tangent of -2 over -2. And let's type that in the calculator. We're going to be in degree mode. So I'm in radians, make sure we're in degrees. So the inverse tangent of -2 divided by -2, and we get 45. Now 45 is not our angle. Remember that when we do the inverse tangent or inverse trig function, that gives us a reference angle, and we have to figure out what quadrant that is in. So if we draw a quick diagram here, here's our coordinate plane. And yes, the inverse tangent of -2 over 2 is 45 degrees, but we need to be in quadrant number 3. we got to be in quadrant number 3 because my horizontal and vertical component are both negative, and we know both two negatives. That's going to put us in quadrant number 3 if we have the x and y part as negatives. So that means this angle is 45 degrees. So our direction angle is going to be 180, half a circle, plus this 45. So theta equals 40, whoops, let me write it down here instead. So theta is equal to 180 plus 45, which is 225 degrees. All right, now in letter B, we have 3 comma negative 2 as our vector. So again, our magnitude is going to be the square root of 3 squared plus negative 2 squared, which is going to be the square root of 13. And we can't simplify that, so we're going to leave that alone as the square root of 13. And then theta, our direction angle, is going to be the inverse tangent of negative 2 over 3. And if we type that into the calculator, inverse tangent of negative 2 divided by 3, oops, we get 33.69 degrees. But remember, that is our reference angle. So if we draw our diagram, we want to be in quadrant number 4. And again, we know we want to be in quadrant number 4 because x is positive and y is negative. So that means my angle, or my terminal side of the angle, is down here. And we got to go in this direction. This is theta. But the reference angle is always from the terminal side of the angle to the x-axis. So that's it right there. Well, we have a full circle almost, except that 33.69. So I'm going to do 360 minus 33.69, and that's going to be 326.13 degrees. All right, I want you to try number 3. So go ahead, pause the video, and when you're done, you can unpause it and see what we get. All right, so you can see my answer. There you have it. Because it doesn't matter that the angle was negative, so the distance between that terminal side and the x-axis was 59.4 degrees, and we were in quadrant 2 because x is negative and y is positive, leaving us to have to do 180 minus that angle to get us that value. All right, now example 1 down here, says a ball is thrown with an initial velocity of 50 feet per second with the horizontal. Find the vertical and horizontal components of the velocity. So that is polar information because we have the magnitude and direction. Our magnitude is 50 feet per second, and our angle is 35 degrees. So to get our components, our horizontal and vertical components, is going to be 50 times the cosine of 35 degrees, comma 50 times the sine of 35 degrees. And then we type those into our calculator. So 50 times the cosine of 35 degrees is 40.96. And if we do 50 times the sine of 35 degrees, that's 28.68. And those are the components. So it's 40.96 feet per second for the horizontal, and then for the vertical, 28.68 feet per second for the vertical component of that. All right, now let's look at the next page. It says find the component form of the sum of u and v with direction angles theta u and theta v. So we're going to add these two angles because it says what is the sum. Okay, so first let's change u into rectangular form, or that component form, by doing 10 times the cosine of 25 degrees, comma, sine, 10 times the sine of 25 degrees. And then, this angle u, not angle u, it's vector u. And then vector v, that's going to be 20 times the cosine of 120 degrees, comma, 20 times the sine of 120 degrees. So I'm going to evaluate these using the calculator and then add up the horizontal components and then add up the vertical components. So 10 times the cosine of 25 is 9.06. And 10 times the sine of 25 is 4.23. And then for v, 20 times the cosine of 120 degrees is negative 10. And 20 times the sine of 120 degrees is 17.32. So now we're going to add these. So u plus v, we don't need these. So u plus v is going to be 9.06 plus negative 10, and that gives us negative 0.94, and 4.23 plus 17.32, and that's 21.55. So yeah, for problems like this, you have to convert it to rectangular form and then add them like we did yesterday. And now we have our component form of the sum of those two vectors. All right, now our last example says three forces with magnitude 65 pounds, 35 pounds, and 80 pounds act on an object at angles of 45 degrees, negative 30 degrees, and 125 or 120 degrees respectively with the positive x-axis. Find the direction and magnitude of the resultant vector of the force. So we're going to do something similar to what we did right here, but we're going to take it a step further. We're going to have three vectors that we're adding, and then once we add those three vectors, we're going to find the magnitude using that distance formula, and then using the inverse tangent to get the direction angle. So let's label these so we can talk about them easier. The 65-pound one I'm going to call U. The 35 one I'm going to call V. And the 80-pound one I'm going to call W. Maybe we should use different colors. So we'll call this one V and U. So 80 pounds, that's the third one on my list, goes with 120. 65 pounds goes with 45. And 35 pounds goes with negative 30. So U, vector U, is going to be 65 times the cosine of 45 degrees, comma, 65 times the sine of 45 degrees. So let's type that into the calculator. 65 times cosine of 45. And yes, I know 45 is in the unit circle, but because we're going to be adding these all together, it's just easier to use the calculator. So it's going to be 45.96. And then 65 times the sine of 45. It should be the same thing. Yep. 45.96, because we know sine and cosine are the same at 45 degrees. Okay, let's go to V. That's going to be 35 times the cosine of negative 30 degrees, and 35 times the sine of negative 30 degrees. So we'll do that in the calculator. 35 times cosine of negative 30. We get 30.31. And then 35 times the sine of negative 30, we get negative 17.5. And then our last one, oops, I did U twice. I want this to be W. W is going to be 80 times the cosine of 120 degrees, and 80 times the sine of 120 degrees. So what's happening in this problem is that, like, it can be thought of as three people are pushing this object in different directions with different forces. You know, someone's going to be the strongest, and it's going to not, but it's not going to go only in that direction. Like, the other directions, other forces are going to affect how it's moved. All right, so 80 times the cosine of 120 is negative 40. And then 80 times the sine of 120 is 69.28. So now we're going to add all of this up. So the vector u plus v plus w, if we add up 45.96 plus 30.31 plus negative 40, I get 36.27. And if I do the y parts, 45.96 plus 17.5 plus 69.28. So this should be negative 17.5 there. I missed it reading it from my calculator. So now if we add up all the y components, we get 97.74. Let's go back to blue. 97.74. So all these forces being added together, the object's moving 36.27 in the x direction, and then 97.74 in the vertical direction, and that's in quadrant 1 because both the x and y parts are positive, which makes the direction angle easy. So our direction angle is going to be the inverse tangent of 97.74 over 36.27, and that's going to be 69.64 degrees. We don't have to worry about adding or subtracting 180 or 360 because we are in quadrant 1, and the inverse tangent gives you angles in quadrant 1 or quadrant 4. It gives us that reference angle. So now the magnitude of our vector, magnitude is going to be the square root of 36.27 squared plus 97.74 squared. And if I type that in the calculator just like that, I get 104.25 pounds of force. So with these three forces acting on this object, the resultant, what is actually happening to this object is that it has a force of 104.25 pounds being pushed at 69.64 degrees. Right, so that is it. Like, the math behind this isn't that hard. We're using just sine and cosine and adding. A lot of calculator stuff. So thanks for watching. Make sure to like it and subscribe.